In this video, I'm going to show you how you could use your phone to control your room light by simply connecting with an old Bluetooth player and using a signal sound generator application to switch on and off the room light without stressing to the wall switch. So with that being said, let's get started. MP3 players, music boxes, or Bluetooth players, whatever they are all called, they are all the same. For some people, it's an MP3 player, and for some, music boxes or Bluetooth players. And some people might even call it an audio player. But we don't know, there could be other things which could be very useful with this. So I'm going to be taking out one of these circuits. So finally, we are going to be using this beautiful music player. Within a second, I will get this open. And now the job is done. I told you, within a second, done. No, not like cooked. I mean, done. Okay, this is a circuit, and we're going to be taking it out. So sorry music box or whatever the name you're being called. I'm going to be taking out your brain. So here is a circuit. I just have the belief that this circuit is still okay. The real problem with this circuit is just that it lost its charging port. So that's not a problem. We are still going to be using this. If you're someone who is curious like me with the digital multimeter, using it to test resistance, capacitance, DC output, AC output, or input of a supply voltage in a circuit, you will always notice, if you've ever come across a Bluetooth player or audio player, you always notice that if you test the output of a Bluetooth player, you always notice a zero reading. But wait a second, this is strange to me. Then how do we hear the sound from a speaker output? Funny, right? No. But if you take that back to AC mode to test the AC voltage, you will notice it reads, but a very little volt, because it produces AC signal. But we need to trigger an NPN transistor. But what do we do? So I thought of it. We need this powerful man. But though it's little, but it's powerful. Its work is to block AC and allow DC flow. So what I'm going to do, I'm going to block that AC and let DC flow. If we test the output after the diode, we will notice a DC voltage of around 1.5, but this isn't enough. We need to boost this to around 3.5 volt using a voltage booster. So here in the circuit, we have the diode which blocks the AC and lets in the DC flow, and we have two capacitors that's going to help to boost this voltage. So at here we should have a voltage of around 3.5, and we have a 330 ohms resistor to limit too much current, not to destroy this transistor. So to allow current to flow from the collector pin down to the emitter pin, then we have another resistor to limit too much current, and then open this other transistor so that current can flow all the way from the optocoupler, and then turn on the LED and to the emitter pin, and to turn on this guy. Hey, did you just really call me a guy? Yes, I did. Shut up. To turn on this relay coil, and do not forget to add a freewheel diode. And when the relay is triggered, this switch is closed. Then the lamp comes on. So this is how the circuit works. Without wasting much of the time, let's get building. But first, we need to boost the output of this. So we need the two capacitors and one diode. So with the negative output, I'm going to be putting this to the ground. So with the positive, you could place that to any of the vertical lines. Next, with the positive leads of the capacitor in line with the diode. I think I should take this way so that you could see better. And next, also the diode, also in the column. And next, with the capacitor, also with its positive lead to the diode. And also connecting all the negative leads of the capacitors to ground. I think I should bring that closer to the camera so that you can see better. So we are done with this. So we need our 3 switching devices: the relay, optocoupler, and transistors. Placing your BC547 like this, and the next connecting their 2 collector leads, in contact with each other. The 2 collector pins in contact, and placing a 33K to the base and emitter pin, and also with a 330 ohms resistor to the positive side of the capacitor and one of its leads to the base pin of the transistor. Not this way. Wrong. I said the base pin. So taking this and hooking up into the base pin. Next, with a jumper wire, connect the leads of the emitter pin to also ground, which is the second transistor. And next, with an optocoupler, I'm using a PC817 optocoupler, and they can also be called photocouplers. So if you look at this photocoupler closely, you will notice a little dot. So that's our input voltage, which the dot signifies the anode pin, and then the second one is the cathode pin. So with the cathode pin, placing your jumper wire to the collector pin with the cathode pin of the optocoupler, and placing a 330 ohms resistor to the anode pin and to the positive VCC. And next, with a 6-volt relay, I'm using a 6-volt relay. Remember, not a 12-volt relay, a 6-volt, because I'm going to be using a 6-volt battery. And then remember to add a freewheel diode for voltage spikes. After done with that, connect a jumper wire to one of the leads of the coil to the positive VCC. Remember, the positive VCC. And also connect a jumper wire to the collector pin of the optocoupler and to one of the leads of the coil, and its emitter to ground. That's ground, like to be grounded. And connect the leads of the capacitor also to the ground, and also doing the same here, connecting their leads again to the ground. Here too is also going to be the ground. So they can start from here. All these points are all grounded to this point, so they have connection with each other. And next, with a 6-volt supply, connecting it to the VCC, the second point. Is that the second point or the first point? Yes, the first point, because the second point was the ground, remember. And next, remember to connect these 2 points, because we have no connection between these 2 points. So I'm going to be adding jumper wires so that they can have connection with each other. And don't forget, you're going to do it for all sides, both up and down, like this, like what I've done right now. You can see they are all connected. So I think now we are done with these circuits. So the last thing we're going to be doing now is to connect our negative supply to the ground, and then that is done, and we are going to be powering this. But wait, guys, not so fast. We have to connect the lamp, connecting one of its wires to the COM pin of the relay and one of its terminals to the normal open switch of the relay. Exactly, that's done. So let's power this. So here is a plug. I'm going to be taking this to the AC and plug it to my socket, and I've done that already. And then we power this on, and I have my phone powering it on, and then going to Bluetooth to connect to this device. First you have to connect to this device, exactly. So I have to go to Bluetooth and device found, connecting already. Until we wait, and connected. So with this app called All Tools, it has a lot of apps inside of it. That is why it's called All Tools. So I'm going to go straight down and look for a frequency sound generator, so we could use its signal to power on and off our light. So it has sawtooth waves and square wave and sinusoidal signal. So if I turn this on my device, wait a minute, it's not coming on. It's supposed, and off, nothing's happening. But what's really going wrong? We have to check the circuit. So here there is a mistake here. If you look, this is not in contact with one of the leads of the relay. So we're taking that out from there and hooking it straight to the relay coil. Yes, the relay coil. So it's time to test this and turn on. Ta-da! It works! And off, but it delays to off. Why? The capacitors are holding charges when the light is being switched off, and which keeps it for a second before it goes off. So we are going to need to add a resistor in between the capacitor so that it could discharge it immediately after which the light is being off. So here is the resistor we needed to add between the capacitor so that it could discharge this light immediately. So now it works better. You can add a more higher value than mine so that yours can work more better than my own. And if you love this video, do not forget to hit the subscribe button, and if you're new here, and also drop a comment and let me know what your thoughts are about this video, and also share this video for your friends, family, and also other people you know. So let's take this out. Oh, this pop's so hot. I need to take this out. Okay. Ouch, it burns. So I'm going to be testing with an energy bulb. And switch on, and switch on, and switch off. It goes off. Until we meet again next time.